Thanks to CuriosityStream for supporting this episode. Go to curiositystream.com/SciShowSpace to start streaming thousands of documentaries and nonfiction TV shows. Humans discovered the first planets beyond our solar system in the ancient days of 1992, and since then the number of confirmed exoplanets has ballooned to over 4,300. Thanks to that flood of new information, we've learned a lot more about planets than our solar system could ever teach us, from what happens when they're born to what happens when their stars die. And along the way, we got a few surprises. First, before we really started studying exoplanets, we thought we had a clear picture of the way solar systems formed. You start with a massive disk of gas and dust surrounding a newborn star called a protoplanetary disk. Then, from that, you get planets and moons and asteroids and so on. But then came a 2018 paper. In it, a team of astronomers was looking at several hundred solar systems with similarly sized stars. They were comparing the mass of all the planets in the older systems with the masses of protoplanetary disks in the newer ones, and what they found was a bit of a mismatch. There seemed to be more mass in the planets than in the protoplanetary disks. That suggests that the disks those planets formed from didn't have enough material to form them. And since matter can't just come from nowhere, clearly something was wrong here. Exactly what happened is still a bit of a mystery, but thankfully, we have some ideas. One possibility is that the planets got a mass boost by siphoning off material from the surrounding interstellar medium, the gas and dust between stars. Another idea is that there was enough mass at the very beginning, like in the first few million years, but then the planets gobbled it up so quickly, our observations missed it. If that were the case, though, the planets would be a lot more likely to balloon up to Jupiter's size, and as far as we can tell, the most common planets are a lot less massive than that. So a third option is that we're just not looking at the right material to get a good estimate of what's out there. For example, astronomers can extrapolate the total mass of a protoplanetary disk based on how much carbon monoxide gas they can detect. But if a lot of carbon monoxide is frozen solid, it won't be detected, meaning the total mass estimate will be too low. Either way, it seems that planets' births are not quite as simple as we thought. And neither, it seems, are their early lives. Back in 1995, astronomers detected an exoplanet called 51 Pegasi b. It's a gas giant that orbits really close to its star, once every 4-ish Earth days. Today, we call planets like that hot Jupiters, and we've found tons of them. But back in the 90s, the existence of hot Jupiters rewrote the textbooks. So we used to think planets just formed in one spot and stayed there. Except, hot Jupiters wouldn't be able to form that close to their stars based on the traditional understanding of things. They're made of hydrogen and helium along with ices like methane and water, and that close to a star, there just aren't enough of those materials to make a gas giant. So we have had to revise our ideas. Today, researchers think hot Jupiters like 51 Pegasi b do form farther away from their stars, where it's cold, but then they undergo planetary migration. That's where the gravitational pull from dust in the protoplanetary disk, or even from small, almost planets, changes a planet's orbit. In the case of a hot Jupiter, it migrates inward to a much closer orbit around its star. Finally, studying exoplanets also taught us something that seems almost unthinkable. Planets might be able to survive the death of their star. See, not all stars have the mass to go supernova and obliterate everything around them, including stars like our sun. Instead, they swell into red giants, consuming nearby planets in the process, and then they will shed their outer envelope as the core collapses into a remnant called a white dwarf. It's a less violent death, for sure, still fairly violent. For example, it can knock planets out of their orbits or bring them so close to the white dwarf that they are torn apart. So when the time comes for our sun, Earth will, in the very best case, be rendered uninhabitable. But in another system, a distant enough planet might survive this, and according to a paper published in Nature in 2020, we may have found one that did. NASA's TESS Space Telescope has been monitoring the light emitted by a selection of white dwarfs to see if their signals periodically dip, which would hint that a planet is blocking some of the light as it orbits. And the researchers found that telltale dip in the signal coming from WD 1856, a 6 billion year old white dwarf around 80 light years away. Whatever is blocking that tiny bit of the starlight orbits every 34 hours, which is way too close for it to have been there before the star died. So instead, the team thinks it started out over 50 times farther away. Then, as its star transformed, it got knocked out of its standard orbit, probably likely thanks to a combination of the star's changing gravitational pull and the influence of other large planets nearby. There's just one caveat here. Because of observation limitations, this body might not actually be a planet. It could be a brown dwarf, something too big to be a planet but too small to really qualify as a star. Still, it's hinting that something a little more Earth-like could survive a star's death if it gets very, very lucky. So overall, the explosion of exoplanet research has made us rethink much of what we thought we knew about planets' life cycles. The universe is far more complex and interesting than we gave it credit for. And if these discoveries are any indication, exoplanets still have a whole lot to teach us. If you want to keep learning about topics like this, you can check out CuriosityStream. They are a subscription-based streaming service, and they offer thousands of documentaries and nonfiction TV shows that stream to any device at any time, including smart TVs. They have content about everything from food to travel to history, and also plenty of good space and physics videos. If you like SciShow Space, you might want to start by watching Amazing Gravity, a two-part series about this bizarre force of nature. Or you could try any of their award-winning exclusives and originals. You can learn more at curiositystream.com/SciShowSpace. And if you sign up with the code SciShowSpace, you can get a year of CuriosityStream for just $14.99.